Assalamu alaikum dear students. In the series of learning C programming, we have discussed file handling in C. In the previous video, everything regarding the file handling have been thoroughly and minutely discussed. And from today, we are going to discuss one more concept of C, that is the dynamic memory allocation in C. In today's video, we are going to discuss, we are going to learn, we are going to see what is dynamic memory allocation. What is the difference between the static memory allocation and dynamic memory allocation? What are the functions which are used for dynamic memory allocations? Or we can say how the memory is going to be allocated to the program dynamically. And also we will discuss in today's video what are the advantages, or we can say or disadvantages of static memory allocation. Everything introduction to dynamic memory allocation will be discussed in today's video very thoroughly and minutely with the help of the program. And in the next videos we will discuss the various functions, we can say sub-concepts of this dynamic memory allocation one by one. So our today's topic is what is dynamic memory allocation. We know that as static memory allocation or dynamic memory allocation. SMA, static memory allocation. That means to allocate the memory at compile time. That means a memory allocation of memory at the compile time. And dynamic allocation, memory allocation means allocation of the memory at the runtime. But static memory allocation means that memory is going to be allocated at compile time, and dynamic memory allocation means memory is going to be allocated at the runtime. But no memory is going to be allocated at the compile time. That means at the compile time, at static memory allocation, no memory is going to be allocated. Then why we say that the static memory allocation means the allocation of memory at compile time. Now, I will write here a small program. With the help of that program, we will discuss what is static memory allocation. First, we will discuss what is static memory allocation. So, first of all, I am going to write here a small program, C program, a simple program. For example, this is my simple program, void man integer a comma b printf enter value of a scanf %d and address of a and printf enter value of b scanf %d address of b printf %d a comma b return 0, or we can say int man. Here I have written a program, a small program, which will take two values from the user and will display that two values on the output screen. It's a small program in which I have declared the two variables a and b. With the help of this program, we will discuss what is static memory allocation, or I can say memory at compile time. We know that memory is going to be allocated to the program, to the variable, only when the programs are going to be executed in the RAM. Only their memory is going allocated to program when they are going to be loaded in the RAM. We know that while we are going to compile a program, actually we have written this program in the high-level language, in a simple English language, and in order to understand these instructions by the computer system, by the machine, it has to convert, it has to, we can say it has to convert into a machine language. It has to go, this is the source program. We can, in other words, you can say this source program has to convert into object program. That means it has to convert into machine understandable format, first of all, with the help of the translators, compile. So at the compile time, what is going to be happen? In compile time, actually, this program, these instructions are going to be converted, going to be translated into the machine code, into the object code. This is source code. So .obj file, object file is going to be created. And after object file, then we can execute for a .exe file and then linker, loader, every that process is going to be performed. After that, the memory is going to be allocated to these variables. Then here I have declared two variables, int a and b. That means we know that integer occupies 4 bytes of memory or 2 bytes of memory, depending upon the compiler, depending upon the machine. Some machines occupy space of 2 bytes for an integer, and some allocates 4 bytes for integer. But I am assuming that I am using a machine which allocates 4 bytes for an integer. So here, what is going to happen here only, when I am going to declare this variable integer a and b, we know that integer occupies 4, that means 4 bytes for this a and 4 bytes for this b. That means total of 4 plus 4, 8 bytes of the memory are going to be fixed, not allocated. Take care. At this junction, only the 4 bytes of the memory are going to be fixed. That means A and B, for A and B, 8 bytes of memory are going to be fixed. We can say at compile time, the memory is fixed, not allocated. That means we cannot increase or decrease, or you can say we cannot modify this memory at the runtime. Okay, are you getting? That means here and at compile time, we can say static memory allocation, what is called, at compile time, no memory is going to be allocated, but the memory is going to be fixed. And at this time, A contains, if I am using I am using a machine which allocates 4 bytes for an integer, that means total of 4 plus 4, 8 bytes of the memory is going to be fixed. We cannot modify this later on. For example, if, 8 bytes of the memory are going to be fixed for A and B, this is the memory for A and B. For example, if I need 10 bytes of the memory. If I need 12 bytes, I cannot increase that memory. I cannot modify this. That memory cannot be allocated at the runtime. At the runtime, I cannot modify it. For example, if I need only 4 bytes of it, I cannot free the memory at the runtime. That memory which I have allocated at the compile time, at static memory allocation. So we can say SMSA means static memory allocation. That means the memory is going to be fixed. At compile time, only the memory is going to be fixed. That means we can, at compile time and runtime. At compile time, only the memory is going to be fixed, not allocated. For example, we can say, next example. For example, if we want, I want to int a of 5. The array which contain, I want to, here at compile time, here I have initialized an array a of 5. That means I can store only 5 members, 5 values in this location. Total of, if the integer occupies 4 bytes of memory, that means 4 into 5, total of 20 bytes of memory will be fixed. That means this is 0, 1, 2, 3 and 4. That I can enter only 5 values at a time, not more than 5. If I need more than 5 values, I cannot enter, I cannot store those values at the runtime. And similarly, for example, if due to some reasons I want to enter only 3 values, for example, here, here and here, rest of the 2 values, that means 8 bytes of memory will remain free. I cannot treat this memory at runtime. So it is the wastage of memory. It is a waste. Neither I can increase nor I can decrease the memory that have been fixed at the compile time. Now we can say at compile time no memory is going to be allocated, but the memory is going to be fixed. The memory that is fixed at the compile time will not be modified later at this runtime. So we see that it results into either the wastage of memory or shortfall of the memory. If later in the program I have fixed the memory 5 elements, in later program I want to store 8 values. I could not store 8 values due to the shortfall of the memory, because I have fixed the memory only for 5 elements. Or it is also possible that at runtime I want to enter only 3 values, and the memory space that have been fixed at compile time will remain unused, and that will result into the wastage of the memory. So we can say that this runtime memory or static memory allocation, what we say, it results either into the wastage of memory or into the shortfall of the memory. That we cannot modify the memory that have been fixed at compile time at the runtime, at the execution time. So, in order, or one more example, if I want, for example, if I want to store the name of students, for example, for that I have declared here char string of 30. Here, at the compile time, I have declared a string whose maximum size is 30, and I want to, for example, Yousuf to store. We know that 1, 2, 3, 4, 5, 6 and 7. Only 7 bytes of the memory will get utilized. For example, this string and these are the 30 size. 1, 2, 3, 4, 5, 6, 7. Only these 7 bytes Y, O, U, S, U, F and /0. Only these 7 bytes of memory will get utilized, and rest of the memory, 30 minus 70, that means 23 bytes of the memory will get wasted. Because I have fixed this memory of 30 for Yousuf, but later I am only entering the string of size 7. So we can say that the compile time, the memory, this static memory allocation, I can say a compile time memory, allocation of memory will result into the wastage of the memory. We know that the memory is the crucial resource, and we have to use it judicially, efficiently. Only those softwares are considered to be the best softwares, which consume less memory and have a fast execution time. The execution rate fast. That means time of execution is less. Those softwares are considered to be the efficient softwares, good softwares. So we have to make it our habit to not to waste our memory. In order to eradicate, we can say this is the disadvantage of the static memory allocation or compile time allocation memory. In order to get rid of this advantage, in order to avoid disadvantage, another concept comes into existence that is called the dynamic memory allocation. That is called the dynamic memory allocation. Dynamic memory allocation. I now hope that you now learn what is static memory allocation, and what are the disadvantages of static memory allocation. Actually, we should keep it in mind that no memory is going to be allocated at the compile time. At the compile time, only the memory is going to be fixed. We cannot increase or decrease, or you can say we cannot modify that memory later at the run time. What is dynamic memory? Dynamic memory allocation means to allocate the memory at the runtime. Actually, the memory is going to be allocated at the runtime. That dynamic memory allocation means that memory is going to be allocated at the runtime. But now the question is how the memory is going to be allocated at the runtime. There are some functions which are used for allocation of the memory at runtime. For example, malloc is the one function that is going to be used. Calloc is the another function that is going to be used. And realloc. These are the functions which are used, and under is a pre that is going to be used to deallocate a memory that has been allocated by using these three functions. So these are the functions which are used to allocate the memory at runtime. Inshallah, in the next video we will discuss these functions in alloc, calloc, realloc, and free one by one. And today's video, before telling something more about this dynamic memory allocation, we must have a knowledge that how the memory is going to be allocated to the program, or we can say how the memory is what is the structure of the memory, how the memory is, what is the layout of the memory. We can say, in other words, what is the layout of the memory. For example, this is our memory, and layout of the memory is just like this. Actually, this memory is going to be divided into four parts, we can say. In other words, there are four. First one, this portion, four portions. Then whenever a memory is going to be allocated for any program, there are four different portions of the memory from where the memory is going to be allocated to the program. So, first one is this portion, small portion, which is there. This is for code and text. Code and text. Whatsoever code, whatsoever I am writing, that the memory for that is going to be allocated from this portion of the memory. Okay? And second one portion, that is this second one portion, it is for the global and static variables. Global and static variables. And this third portion is for stack. And this last one is the heap. Actually, the major portion of the memory is that is going to be allocated to the program at the runtime is from this heap. Heap is the long, you can say it is a long pull-up, big pull-up memory. The memory is, maximum portion of memory is going to be allocated from this heap to at the runtime, to the programs. So, we know that in the program we use some static variables and we use some global variables. The memory for those variables is going to be allocated from this portion, global, this portion. And this code and text is for writing the text and the code. And this state is for functions. And local variables. Functions and local variables. That means whenever we are going to write some program, some functions, to that function, some variables we declare some variables as a global, some as a static, some as a local. If the memory which is going to be utilized by the global and the static variables are going to be allocated from this portion. And the memory for functions and local variables is going to be allocated from this state portion. Mainly this state has a small memory. It is not a big memory. And we should also keep in mind that this heap and what so called this stack is growing in opposite direction. If stack is growing just like this, then heap would be in this direction. This stack and heap are always going in opposite directions. Okay, for example, here we will take an example. Here, we know that if we take the example of this memory, this program, 8 man, here I have declared a man, a function man. For this man function, for this man, the memory will be allocated from this. This is a portion of the memory allocated for example, this for man, and it will be allocated from this portion, function, this stack, because memory for this man, the function are going to be allocated from stack portion. And in this case, there are two variables, A and B. We know that this A and B are local to this main program. So, also, it will contain two variables, A and B. These are the local for this, and also the memory for this is going to be allocated from this stack portion as well. Now, under is the printf. After that, there is under printf. Printf means, what is printf? Printf is a function. Also, some portion will be allocated for under function printf. And after execution of these lines, value of A, value of B, and next under printf, then scanf, then printf, then return 0. Next, after execution of these lines, we should make it a habit to free this memory. When this line gets executed, printf, this function gets freed. After that, next printf, and another one is the scanf. Okay, because I have used 4 functions here: printf, scanf, and last printf. That means 5 rather than 5 functions. And memory for these 5 functions are going to be allocated from this stack only. So after execution of these lines, first this printf, the memory which has been occupied by this gets freed. After that, for scanf, then for this kind of, then, and last, after return 0 here, then the control will reach here, this man will get erased. The contents of man is detected, that we can see the man will get freed. So, this is only how the memory is going to be allocated to the program. For function, we know that the layout of the memory which is going to be allocated from there to the program are from these 4 sections. First one is the code and text, for this code and text. And second for global, and if I have declared some variability global, some static, for that the memory is going to be allocated from this portion. And for function and local variable from, and heap, for every execution, main memory that is going to be allocated is from this heap at runtime. That means whatsoever the memory we are going to use at the runtime is from this heap memory only. And that will be inshallah discussed in the next video, where we are going to discuss the function malloc. There we will discuss the function malloc. How the malloc function is used for allocation of the memory at the runtime. So that will be discussed next. But we should make it our habit that after using this memory, we must free this memory at the end. I hope now that you have understood what is static memory allocation and what are the advantages of static memory allocation, what are the disadvantages of static memory allocation, what are the functions which are used for their static, and what is the difference between the static and the dynamic memory allocation. Simply we can say that dynamic memory allocation is the allocation of the memory at the runtime. The memory which has been allocated at the run, that can increase or decrease it. That means we can allocate the memory to the program as per the need of the program. That is possible only when we are using this dynamic memory allocation. So we can increase, we can decrease the memory, we can update the memory if that has been allocated at the runtime, or we can say dynamic memory allocation. Inshallah, in the next video, we will discuss the first function, that is the malloc function, which is used for allocating the memory at the runtime or dynamically. Till the next video, take care. Bye-bye.